Okay, hello students. Everything you see in front of you here is the speed of light apparatus. And so using this equipment, you can actually measure the speed of light, which is the point of this lab. So what I'm going to do is just sort of run through all the pieces here, tell you what they do, and I'll give a few more specific details. So to start with, this metal box right here is a so-called transmitter receiver here. So what it is inside of this is some electronics that has a very bright LED that can be pulsed on and off, and it sends the pulses of light out of this aperture here, so it can go this direction. The other thing that the box has in it is a receiver. So if light happens to come back in this direction into the aperture, it can be picked up by a receiver and then routed out through an oscilloscope. So you can see it's just basically a box, and there's some cabling coming out of the back. There's a power cord right here, and I have two coaxial cables connected to it. And we'll talk about what those connections are in just a moment. The next thing that we have right after the transmitter is a big plastic Fresnel lens. So it turns out that LEDs, as is used in the light source here, are not lasers, so it's very hard to collimate them and sort of contain the light so it can be sent over long distances. In other words, even with some lensing inside the aperture here, the LED light still tends to spread quite a bit. It's very difficult to collimate an LED, and so what this is here is a huge plastic so-called Fresnel lens. You should definitely look it up on the internet. They're very interesting devices. It's a piece of plastic that has a bunch of grooves in it, and the grooves sort of emulate what a converging lens would do, but because it's made out of plastic, you can make really large ones. And so everything inside this wooden frame here actually is collectively something that behaves like a converging lens. Why would you sort of put it like this? Well, this is about the focal length of this Fresnel lens, the distance that you see here between the transmitter receiver box and the lens. And so if you remember from your classical optics, if you have something that's like a converging lens placed one focal length away from an emitter, it'll take the diverging light that's diverging and collimate it as much as possible. So in other words, when it reaches this side of the Fresnel lens, the light becomes somewhat parallel, although as I said, it's very difficult to do with LEDs in this setup. It does a pretty good job, but we definitely don't have a really good bundle of parallel light coming out, but certainly good enough to run the experiment. And the last bit you have over here is a big reflector. So this slab of plastic on here is just some reflecting plastic that looks almost exactly like the reflectors that you would have on your bicycle. And so what I mean by that is I believe there's a bunch of corner cube reflectors embedded into this plastic here. And what the corner cube allows you to do, you should definitely look that up too, is no matter what direction light comes in, it always sends it back in the exact direction from whence it came. And so that's sort of a big retroreflector. So it's better than a mirror in a case like this because A, it's really large, so it's not going to be very expensive, and sort of more durable, and definitely because of that the corner cubes that are in here sends light back in the direction from it came, sort of not exactly following the law of reflection, say that a flat mirror would do, in which case we might lose a lot of light in that case there. Okay, and then lastly, of course, we have the oscilloscope over here, which at the moment has some pulses on them. So in the next video, what I'll do is I'll tell you a little bit more about this electronic box here and sort of how the experiment is run.